Welcome to today's video on Cambridge IGCSE Mathematics 0607 and 0580. The topic for today is geometry, where we will be looking at the subtopic similarity. To start off with, we're going to go ahead and look at the concept of congruency. Now, when we have congruent shapes, what this means is that we're looking at shapes that have the exact same sides as well as the exact same angles. And if we can prove that two different shapes have corresponding lengths with each other, as well as corresponding angles to each other, then we can call them congruent shapes. When looking at triangles, we have a few special cases that we can use to prove the congruency of triangles. And the first case is where all three sides of our triangles are equal, and we call this SSS. Looking at the diagram I have here, I can see that in these two triangles, they do have all sides corresponding. So the side with one hatching each corresponds to the other. Then we have the sides in red because both of them have two hatchings each, they corresponding with each other. And then finally, the last side, which has three hatchings each, they also correspond to each other. And because they have all three equal lengths, we can say that this falls under the case of SSS, where all of their sides are the exact same. So this means that these two triangles have to be congruent to each other, and this also means that their angles would also be corresponding. The next case that we have is SAS, and what this stands for is side, angle, and then another side. So looking at this, I can see that this side in green and the other side that I'm marking in green are corresponding with each other. So are the sides that I'm marking in red. And when we deal with the angle in SAS, you need to make sure that it's the included angle. And what we mean by the included angle is the angle that's sandwiched between our corresponding sides. So the angle that's between our green and red lines is what we would call the included angle. And if this included angle is the exact same, then we can go ahead and say this is falling under the case SAS, which means that these two triangles are going to be congruent to each other, and they would have three similar lengths as well as three corresponding angles. Our third case that we have when proving congruency with triangles is AAS. And what this stands for is angle, angle side. So if I can take a triangle and prove that two angles are the same, as well as one side in each correspond to each other, then it falls under the case AAS. So you can see that in the diagram we have here, we have two blue angles. So it means that they are equal angles, and two pink angles, which are also showing that they're equal in magnitude. So two angles that are the exact same, as well as one length that they've marked here. That's the exact same, showing us this is another case of congruency. And then our final case that we can use to show congruency in triangles is RHS. And what this stands for is right angle, hypotenuse, and side. And this is a case that we can just use specifically for right angle triangles. Right angle triangles are triangles that have one 90-degree angle in them. And the hypotenuse in our right angle triangle is the side that's right opposite this right angle. So if we can show that the right angle is present, as well as this length of the hypotenuse is exact same, and the length of one of the other two sides are also corresponding with each other in both our triangles, then we can say that this falls under the case of RHS, and these two triangles over here would be congruent to each other. So there we